Okay, so projectile motion is motion of any object which is thrown in space. Okay, so let's suppose I take a ball and throw it in space. What kind of path will it follow? It will follow path like this, right? If I throw it at some angle, it will follow path like this. So this motion is known as what? The projectile motion. Okay, any object projected in space, its motion is known as the projectile motion. So now let's draw trajectory of this projectile. So let's suppose this is my y-axis, this is my x-axis, and I throw projectile, so it follows a path like this, right? So now at the beginning, it will have some velocity. We throw it with some velocity at from this point. Let's call it origin. So x is equal to 0, y is equal to 0. Okay. So this is your x naught, y naught, which is 0, 0, point O. So you are throwing your projectile from this point with some velocity, some initial velocity. And how will the velocity at this start point, how can we draw it? It will be along what? Tangential to the path, right? It will be along the tangential to the path, tangential direction. So this is the initial velocity u bar. Okay, this is u bar, and you can resolve it along two perpendicular components. So the perpendicular components along x-axis and y-axis. So this is ux, the component along x-axis is ux, component along y-axis is uy. U bar can be written as what? What will be ux? Okay, can I write u bar equals to ux times I cap plus uy times j cap? Yes, no?
Yes, sir.
Okay. And we have studied in resolution of vectors that ux can be written as what? Ux is equal to u cos theta and uy is equal to u sin theta, right? So, see, then you can write u bar as equal to what? U bar is equal to u cos theta multiplied by I cap plus u sin theta multiplied by j cap. And what will be magnitude of this u? The magnitude of u bar is equal to square root of ux square plus uy square. This we studied in vectors, right? So see, there is no acceleration along x direction. There is acceleration in y direction only, which is acceleration due to gravity. So motion along x direction, it is uniform motion. Motion in y direction is uniformly accelerated motion, right? Okay. So acceleration in x direction is equal to 0. Therefore, speed in x direction, okay, the velocity in x direction at any later time will be equal to velocity at start. Okay, so can I say Vx is equal to ux? Yes, no?
Yes, sir.
Okay, and since ay is equal to minus g, okay, ay is equal to acceleration due to gravity, but we are considering this direction as positive, vertically upwards as positive. Acceleration due to gravity acts vertically downwards, so it is negative, right? And therefore ay is equal to minus g, and therefore we can write vy, velocity in y direction at any later time, is equal to uy plus ay times t, that is equal to uy minus gt, right? This is velocity along y direction at any later time. Vy equals to uy, which is u sine theta, minus gt. And okay, velocity in x direction, vx is equal to ux. Okay, so this is clear till this point. So we found velocity in x direction, which remains constant, velocity in y direction, okay, which is uy minus gt. So now I want to find out equation for the displacement. So in x direction, the projectile is moving with constant velocity, right? So it is uniform motion, and that's why you can write velocity is equal to what? Displacement covered divided by time taken. So I can say in x direction, for x direction, okay, I can say ux is equal to what? The displacement in x direction divided by time, okay, and this displacement is x at some time t minus x at start divided by time, right? So x at start is equal to 0. You put that and you get what? X at time t is just equal to ux multiplied by t. What is ux? Ux is q cos theta, right? So it is u cos theta multiplied by t. Okay, so let's call this equation 1, this is 2, this one 3. Okay, after that, for y direction, what can I say for y direction? It is uniformly accelerated motion, right? Motion in y direction is uniformly accelerated motion or uniformly decelerated motion. So you can write sy is equal to uy times t minus half of gt square. Okay, because acceleration is what? It is minus of g. So sy is displacement in y direction, which can be written as what? Y at some later time. Okay, y position at some later time minus y position at the beginning. Okay, it is uy times t minus half of g multiplied by t square. So put y0 equals to 0. What do you get? Y at time t is equal to what? Ui times t, which is u sine theta multiplied by t minus half of gt square. Okay, so this is equation 4. Now what I will do is I will divide equation 4 by equation 3. Okay, so I get relation between sorry, what did I say? I will divide. Okay, so in this equation 4, what I will do is I will put um, this time as u cos theta divided by x. Okay, so see what is the equation of trajectory? It is the relation between y coordinate and x coordinate. Okay, so first thing that I want to find out is equation of trajectory. What is equation of trajectory? It is the relation between y coordinate and x coordinate. So how do I find that? So so in this equation, okay, in this equation I have time, okay, and I want the relation between y and x. That is my equation of trajectory. So what should I do? I should I should substitute for x in place of this time, right? I should write the time in terms of x. Okay. So what can I do here? Here I can write t is equal to what? Xt divided by u cos theta. Okay. So let's call this equation 3a or something, and let's put this in this equation. Okay, so what do we get? We get y at time t, y at some time t is equal to u sine theta multiplied by t, and what is t? It is x at time t divided by u cos theta. Okay, so u sine theta multiplied by x at time t divided by u cos theta. This is your t minus half of g multiplied by t square. So t is x divided by u cos theta, and you have square of that. So this is equal to, here u and u gets cancelled, sin theta upon cos theta is tan theta. So this is tan theta multiplied by x at t minus half of g upon u cos theta square multiplied by x at t square. Okay, so this is y at some time t. So this can be written as some alpha. So alpha is equal to tan theta. Okay, alpha times x minus, or I will write plus, beta times x t square, where alpha is equal to what? Tan theta. Beta is equal to this thing, minus half g upon u cos theta square. So this is a constant, this is a constant, and you get this equation for the trajectory. Okay, so equation of trajectory of projectile, or I just want to say trajectory of projectile is a parabola. Okay, or projectile follows a parabolic path. All right, let's do next thing. So now I want to find out the maximum height. I want to find out maximum height of projectile. Okay, so what should I do? So now what we have done is we have broken this motion of projectile along two perpendicular components. Okay, so we are studying x component separately, y component separately, right? So now see what will happen at the maximum height. What will happen when projectile reaches at this point? What will be its velocity?
0.
It will be 0, or which component of velocity will become 0? X component or y component?
X.
No, x component is
Y
constant,
component.
right? X component is constant, right? X component is constant because there is no acceleration or deceleration in x direction. So x component is constant. So when projectile reaches this height, what will happen? Its y component will become 0. Y component of the velocity will become 0. Okay, so velocity at maximum height will be directed in x direction only. And what will be that velocity? So velocity at this point, Vx will be equal to what? It is just u cos theta. Okay, so this is the point of maximum height. Okay, this is the point of maximum height. So I want to find out maximum height. How do I find? Tell me. So at the maximum height, y component of velocity becomes 0. Okay, so at maximum height, y component of velocity becomes 0. Okay, so I can use my kinematic equation. I will use third kinematic equation. So I can say Vy square is equal to Uy square minus a plus 2Ay into Sy. So for maximum height, the displacement will be equal to Sy. Okay, so H is equal to Sy, and what is acceleration? It is minus g, right? Acceleration is minus g. So Vy is equal to 0. Let's substitute that. It is equal to Uy square, and we have minus 2 times g into h. Okay, so which gives me 2 times g multiplied by h is equal to uy square. So h is equal to uy square divided by 2g. And what is uy? It is u sine theta. So h is equal to u sine theta square, or I can write u square sine square theta divided by 2g. So this is the maximum height attained by a projectile thrown at an angle theta. This is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now when this height will be maximum, at what angle with the horizontal will this height be maximum? Tell me.
90-degree.
90 degrees. So in this equation, for the maximum height, you have u square sine square theta divided by 2g. So u is constant, g is constant. Okay. So theta can change. The maximum value of sine theta is equal to 1, and it happens for the angle theta. So I can say h max, the maximum height, is u square upon 2g, and this will happen when sine square theta is equal to 1. That means theta sorry, sine of theta is equal to how much? It is 90 degrees. Okay, so the projectile goes till the maximum height when it is projected vertically upwards. Next thing, so next I want to find out the horizontal range of projectile. Okay, so next let's find out the horizontal range of the projectile. Okay, so your projectile is projected like this. So now suppose this is a horizontal surface. This is a horizontal surface. So now at this point, what is value of y? Y is equal to 0 at start, right? And at this point also, y will be equal to what? 0.
Yes, sir.
Yes, sir.
Okay. So now
Yes,
first
sir.
we want to find out the time when this projectile lands on the ground. Okay. So whenever it lands on the ground, y will be equal to 0 for that. Okay. So I have equation for y coordinate. Y is equal to what? It is u sine theta multiplied by t minus half of g multiplied by t square. So now till the time this projectile is in air, that time is known as time of flight. Okay, so till the time it is in flight, okay, the time, that much time is known as the time of flight. Okay, so what is time of flight? Sorry. So what? So t is the time of flight. Okay, it is the total time spent by projectile in air. Okay, so at the end of t, capital T, what will happen? The projectile will land on the ground, okay, on the floor, and at that time, what will happen? The y coordinate will become 0, right?
Yes,
Yes,
sir.
sir.
Okay, after that much time, y coordinate will become 0, and we want to find out that time. Okay, so see, now let's substitute y is equal to 0. So when at t equals to capital T, y is equal to 0. So let's substitute that. If we substitute that here, what do we get? 0 is equal to what? U sine theta multiplied by t minus half gt square. And therefore, half gt square is equal to u sine theta multiplied by t. So your t and this thing square gets cancelled, so you get t is equal to 2u sine theta divided by g. Sorry. So how much is the time of flight? What is the equation for time of flight? It is 2u sine theta divided by g. So now the distance covered in this time in horizontal direction, it is known as the range of projectile. Okay, so what is the range of projectile? Range of projectile is denoted by r. So range r will be equal to what? It is distance covered by projectile on the ground. Okay, the horizontal distance covered by the projectile is known as its range. Okay, so it takes this much time to cover that distance, and we know what is the distance covered in x direction. X is just equal to ux times t. Okay, velocity multiplied by time. So x, so at t equals to t, x is equal to the horizontal range. This is clear?
Yes, sir.
Yes, sir.
Okay, so r is equal to, I can say, ux multiplied by capital T. So it is equal to, what is ux? U cos theta multiplied by capital T is 2 times u sine theta divided by g. Okay, and you can see here, this is 2 times sine theta cos theta is formula for what?
Sine 2 theta.
Is sine 2 theta, right? So you get r is equal to u square. Okay, this u multiplied by u square sine 2 theta divided by g, sine 2 theta divided by g. Okay, so now tell me, at what angle should be projectile projected such that it will attain maximum range?
90 degree. No, 45 degree.
45 degree. Okay, here you
Yes,
have
sir.
sine of 2 theta, right? So u is constant, g is constant. Okay, sine can have different values. So for maximum range, for the maximum range, I can say r max. Okay, maximum range is r max. Sine of 2 theta is equal to 1. Okay, so that means 2 theta should be equal to 90 degrees, and that means theta is equal to what? 45 degrees. Okay, sine of 2 theta is 1, that means 2 theta is 90 degrees, so theta is equal to 45 degrees. So when you throw, if you play cricket, okay, at what angle should you throw the cricket ball such that you have to throw it with minimum efforts? You got this? Okay, let's suppose you are at the boundary. Okay, you are playing cricket, you are fielding at the boundary here. Okay, and these are your stumps. Okay, this is the pitch, this is bowler's end. So now you throw the cricket ball. Okay, you fielded that, and you throw it to bowler. Okay, batsman is taking runs. So you should throw it at what angle such that you have to throw it with the minimum efforts. Okay, so theta should be equal to what? Should be 45 degrees.
Yes, sir.
Yes, sir.
You got this
Yes,
or
sir.
not? This is clear, no? Okay, because see,
Yes, sir.
you want some range. Okay, this will be your horizontal range. So this can be attained using various angles. Okay, so your formula is u square sine 2 theta divided by g. So if you throw it at what? 45 degrees. So r will be equal to u square divided by g, and that's the maximum range. Okay, so range is fixed. You can change u, you can change theta. That means you can change the velocity, you can change the angle, right? So now let's suppose you throw it at 30 degrees. So what will be sine of 2 theta? It will be sine of 60, right? It will be root
Yes,
3
sir.
by 2. Okay, but r is fixed. This is root 3 by 2. Okay, so if this is root 3 by 2, that means it is 1.7. Okay, 73 divided by 2, it's less than 1. So if this term is less than 1, you have to increase this. That means you have to apply more force, more energy. This is clear?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So, so for maximum range, theta is equal to what? It is 45 degrees. Okay, so let's clear the cricket field. And now, what will be the height? Okay, what will be the height when r is equal to r max? Okay, so for theta equals to 45 degrees, what happens to the height? So h is equal to, we have this formula, u square, what? It is cos square theta, right? Divided by 2g. Sorry, u square sine square theta divided by 2g. This is the formula. Yes or no?
Yes, sir.
Okay,
Yes,
so
sir.
Yes, sir.
maximum height, or not maximum height, the height attained by the projectile, maximum height attained by projectile when you throw it. It is u square sine square theta divided by 2g, and your theta is 45 degrees. So what height does it attain at the 45 degrees? That's what we are going to find. So sine of theta is how much for 45 degrees? 1 upon root 2. Sine square theta will be how much? 1
1
by
by
2.
2.
1 by 2. Okay, so it is u square divided by 2g multiplied by 1 by 2. Okay, so see at this angle, what will be the value of r? So it is r max. Okay, so r max is equal to what? U square divided by g, right? Sine 2 theta is equal to 1. Okay, so so u square upon g is r max. So how much is h? H is equal to r max divided by 4. H is equal to what? R max divided by 4. This is clear?
Yes, sir.
Yes, sir.
Okay, so height will be range divided by 4, maximum range divided by 4 when you throw it at 45 degrees. Okay, clear, Preeti?
Yes, sir.
Okay, good. So then, see, we discussed the time of flight. Okay, so till the time the projectile is in air, that time is known as time of flight. Now, you throw that projectile, it goes till this height. So till this time it is going up. So the time, till the time the projectile moves up, it is known as time of ascent. And when it starts moving down, okay, that is known as descent. So till the time it moves down from this maximum height, till the time it reaches the ground, that time is known as time of descent. Okay, so can we find time of ascent? Okay, time of ascent, time of ascent, let's denote it by ta. Okay, this is what we have to find out. So what will happen at this time? Which component of velocity will become 0? Y component, right, at maximum height. Okay, till what time it will keep
Y
on?
components 0.
Y component becomes 0. Okay, so when t is equal to ta, Vy is equal to 0. Y component of velocity is equal to 0. And what is Vy? It is Uy minus gt, that's equal to 0. It is u sine theta minus gt, this is equal to 0. Okay, so in place of t I will substitute what? Ta. Okay, let me substitute Ta over here. Okay, g times Ta. So which implies Ta is equal to u sine theta divided by g. Okay, okay. So what is time of ascent? It is u sine theta divided by g. How much is time of flight? Time of flight is 2u sine theta divided by g. So how much would be time of descent?
U sin theta by G.
It should be u sine theta divided by g, because total time of flight is 2 times u sine theta divided by g, and time of ascent only is u sine theta upon g. So time of descent, time of descent, okay, Td is equal to t minus time of ascent, that is 2u sine theta upon g minus u sine theta upon g. So it is u sine theta divided by g. This is time of descent, right? Simple.
Yes, sir.
When you throw an object, let's suppose you throw a ball vertically upwards, okay, with some velocity, vertically upwards, okay, 90 degrees, yeah. So when it comes back to you, how much will be its velocity? Is it the same or is it different?
Same.
Same no, sir.
Same.
It will be same, right? So now here, when you throw this projectile in air, okay, with some initial velocity u, okay, this is the initial velocity, and at this point it will have some final velocity. Final velocity will be directed like this. Okay, final velocity will be directed like this. So this is u bar and this is sorry, v bar. This is v bar. Okay, so this angle is theta. How much would be this angle? It would be theta. Why? See, there are two components to the velocity. X component does not change. Okay, x component does not change. What happens to the y component? It gets reversed. Okay, as we throw something upwards, it comes back to us with same speed. Actually, velocity is different because magnitude of velocity is same, right? So initially it is upwards, now it is downwards, speed is same. Okay, so see here, this theta can be written as what? This theta can be written in terms of ux and uy. Okay, you resolve this in two components. This is ux, this is vertical component is uy. So vertical component is uy. Tan of theta is equal to what? It is uy divided by ux. Okay, and now since vy will be equal to ui, the magnitude will be equal. Okay, and just direction is opposite. So this is your vy, which is equal to uy, and which is this is vx, which is equal to ux. Okay, so again now you can write tan of this angle. How much would be tan of this angle? Tell me. if I draw this Vy over here, okay, this Vy, I draw it here. So it is opposite side Vy divided by adjacent side Vx. Okay, so it is Vy divided by Vx. Got this?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay. So now, so this angle, I'm saying this angle and this angle, it will be equal. Why? Because x component of velocity remains constant, y component just gets reversed, but its magnitude remains constant. So this much, okay, this length, and this length is equal. Okay, if you draw x component of velocity here, this is your, sorry, y component of velocity here, this is uy, and y component of velocity you can draw here, y component of final velocity. So their magnitude is equal, right? Their magnitude is equal. So Vy is equal to Uy, okay? And x component of velocity is constant, it's not changing. Y component is changing, but when it hits the ground, it is same as that of initial y component. Okay? So this angle and this angle will be equal. And these two are vertically opposite angles. So that means this and this, they are equal anyways, right? So this angle and this angle is equal. Yes, no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now if you measure angle, okay, if you measure an angle from starting, okay, with respect to positive x direction. So if this angle is theta, how much would be this angle? It is, so projectile which is thrown up at an angle theta with positive x direction hits the ground at an angle 180 minus theta to the positive x direction. Clear?
Yes,
Yes,
sir.
sir.
Okay, good. So this angle would be 180 minus theta. Okay, we are consistently measuring the angle with positive x direction. Okay, and now, so if u bar can be written as, if u bar can be written as ux into I cap plus uy times j cap, how can I write v bar? This v bar, this can be written as, sorry, v bar can be written as vx times I cap plus or minus Vy times j cap.
Minus.
It will be minus because this component is vertically upwards, this one is vertically downwards,
Yes,
Yes,
sir.
sir.
right?
Yes, sir.
So you can equally write this as v bar is equal to ux times I cap minus uy times j cap, because vx is equal to ux, vy is equal to uy in magnitude, but just direction is opposite for vy. Okay, so this is clear. So we have two bullets are fired horizontally and simultaneously towards each other from rooftops of two buildings 100 meters apart. So we have two buildings 100 meters apart. This is building 1, this is building 2, and two bullets are fired like this. One bullet is fired like this, another bullet is fired like this horizontally. Okay, and this distance, horizontal distance, is how much? 100 meters. Of same height of 200 meters. So this height of both the buildings is 200 meters. Okay, with same velocity 25 meters per second, and bullets are fired with the velocity of 25 meters per second. So v is equal to 25, and v for this is also equal to 25 meters per second. So let's call it va, this is vv. Okay, when and where will the two bullets collide? Okay, how much is the distance between the bullets? See, what path will they follow? their path will be projectile motion. Okay, so this bullet, it will follow, first bullet will follow this kind of path, right? If you throw something like this, it will follow this kind of path. Okay, if you throw something in horizontal direction, it follows this kind of path. Okay, a parabolic path, and this one also follows a parabolic path. They will reach at this point. Okay, so how much would be the distance covered by these two bullets? Okay, this is also thrown from this point. Okay, so they are at distance of 100 meters from each other. Okay, with respect to each other. So the relative distance covered by them, if you think in terms of first bullet, so relative distance covered by bullet A with respect to B will be how much? The relative distance to be covered is 100 meters. What will be relative velocity? It is 25 minus 25, 50. Yes, no?
Yes, sir.
Yes, sir.
Getting this or not? Both are coming
Yes,
towards
sir.
each other, no? So, see, S is equal to, now VA would be positive, VB would be negative because it's moving towards left. Okay, so it is VA minus VB multiplied by T. Okay, and it is 25 minus 25, that is 50 multiplied by T. This is 100, so T equals to, it is 100 divided by 50, 2 seconds. So two bullets will strike each other. They will strike at this point, but at what time? T equals to 2 seconds. Okay, so how much vertical distance will they move? Will they cover? So see, horizontal movement and vertical movement. The motion in horizontal direction and motion in vertical direction, they are separated. Okay, so initially both of the bullets don't have any velocity in vertical direction. Okay, there is no velocity in vertical direction. They are fired horizontally, and we know that there is acceleration in vertical direction. So we can use this formula. So distance covered in y direction, let's suppose this much is the displacement in y direction. Okay, this much is the displacement in y direction. Let's call it Sy. How much would be Sy? Sy is equal to, it is equal to uy times t minus half of gt square, and uy is equal to 0. They are fired in x direction. Okay, so it is minus half of gt square. Okay, or if we just want to find out the magnitude, let's keep plus half. Okay, so uy is 0, this thing will be 0. It is half of gt square, so half of 10. Okay, g is given as 10. Even if it is not given, we'll take it as 10 for simplicity. So this is 10 by 2 is 5. 5 times 4, 20.
20 meters.
Yes. So what's the answer?
Option B.
B, sir.
It is option A. See how they cover that much distance, but you want their height. Okay, earlier they were at the height of 200 meters. Now they have fallen through the height of 20 meters. Okay, so they are still at the height of how much? 200 minus 20.
180 meters.
Yes, no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so what's the answer? Option A is the answer. Okay, this is an assertion and reasoning type of question. So the maximum height of projectile is always 25% of maximum range. Okay, maximum height of projectile is always 25% of maximum range. This is true or false?
True.
True, sir.
Yeah,
Yes,
we
sir.
found that. Okay, maximum height is equal to 1/4 of maximum range. 1/4 means 25%. So for maximum range, projectile should be projected at 90 degrees. This is true or false? This is the reason.
False.
This is false. Good. So which of the options is correct?
C.
Sir.
Assertion is correct, but reason is incorrect. Right. So what should be the reason? Correct reason?
Projected at 45 degrees.
Projected at 45 degrees. Good. Next one. So what is the range of projectile thrown with velocity 98 meters per second with angle of 30 degree from horizontal? This is very simple, right? So just the formula for range is u square sine 2 theta divided by g. Okay, so 98 square multiplied by sine of 2 theta, okay, sine of 60 degrees divided by g. How much is g? Well, let's suppose it is 10. Okay, so 98 square, or no need to take 10, no, we have 98 in numerator, so 9.8. Okay, so sine 60 is root
Sir,
3 by 2.
option
Which option?
A. A, sir.
Option A. Right. So it is 98 multiplied by 98 divided by 9.8. So this will be 10. 10 by 2 is 5. 5 times 98 will be 490. Okay, and 490 root 3 is the answer. Option A. Assertion and reasoning type of question. So when theta equals to 45 or 135, the value of r remains the same. Only the sign changes. Okay, only the sign changes. Okay, I forgot to tell you one thing. So what is r? It is u square sine 2 theta divided by g, right? So it is u square sine of now see see this is an angle theta, and suppose this is an angle alpha. Okay, and alpha is 90 minus theta. Alpha is suppose 90 minus theta. Okay, so a projectile thrown at theta and projectile thrown at alpha, they will have same range.
Yes, sir.
No? Why?
Yes, sir.
Because this is 2 times sine theta cos theta upon g. Okay, and for projectile which is thrown at alpha, it will be 2u square, okay, sine alpha cos alpha divided by g. And why so? So projectile thrown at angle theta and projectile which is thrown at angle of 90 90 minus theta will have same range. Okay, because sine of 90 minus theta is how much? Is what?
Cos theta.
Cos theta. And what is cos of 90 minus theta?
Cos theta.
Cos of 90 minus theta? It is cos A cos B cos 90 cos theta plus sin 90 sin theta. Is this formula correct? Cos 90 is 0, so this is 0. So it is sin 90 is 1, it is sin theta.
Yes, sir.
Yes, sir.
Okay, and what is, let's check this thing also. Sin of 90 minus theta is sin 90 cos theta. Yes, this is cos of theta. Okay, minus cos 90, yeah, minus cos 90 sin theta. Okay, so sin of 90 minus theta is cos theta, and cos of 90 minus theta is sin theta. Okay, so this is alpha is 90 minus theta. So sin of alpha is equal to cos theta. Cos of alpha is sin theta. Okay, so this will be equal to what? Sin alpha cos alpha is equal to what? sine theta cos theta, right?
Yes, sir.
Yes, sir.
And that's why they will have the same range. Okay, a projectile which is thrown at theta with horizontal, or which is thrown at which is thrown at what, 2 theta, not 2 theta, 90 minus theta with horizontal will have same range. Okay, this is clear.
Yes, sir.
Okay, so please add this point to your notes. Okay, for quick answer. Sometimes there can be a question. A projectile is thrown at 30 degrees, okay, with such and such velocity. A projectile is thrown at 60 degrees with some velocity. Okay, so first one goes till 100 meters. Next one will go till what? We don't need to calculate. It will go till 100 meters. When theta is 45 or 135, the value of r remains same. The only sign changes. Okay, so this is like common sense. Theta is 45, okay, and theta is 135. 135 will be in just opposite direction. Okay, so range will remain same. Okay, so this angle will be 45 then if you throw it at 135. So range will remain same. Only
Both are correct.
both are correct.
Both are correct, sir.
Both are
Right.
correct, sir.
So which is the answer? Option A, right? If the angle of projection of a projector with same initial velocity exceed or fall short of 45 by equal amount alpha. Okay, angle of projection of projector with same initial velocity exceed or fall short of 45 by equal amount alpha, then the ratio of horizontal ranges is. Okay, who can tell me what to do? What's given in the question? Projectile, this is 45 degrees. Okay, angle of projection, this is suppose theta. It is either 45 minus alpha, falls short of alpha, or it is 45 plus alpha, exceeds or falls short of 45 by equal amount alpha. Then the ratio of horizontal ranges is. Okay, let's try to solve this. So let's say first angle is theta 1 and the second one is theta 2. So theta 1 is 45 plus alpha. Theta 2 is 45 minus alpha. Got this?
Yes, sir.
Okay. So what will be range? Range is just directly proportional to what? Sine of 2 theta. Okay. So R1 is to R2 because they are projected with same initial velocity. Okay. R is equal to what? U square sine 2 theta divided by G. U is same, G is same. So it depends on, okay, that's 2 theta. It depends on what? Theta only. Okay, so R1 upon R2, I can say R1 upon R2 because it's proportional to sine theta, sine 2 theta. It is sine 2 theta 1 upon sine 2 theta 2. Can I write this?
Yes, sir.
Okay,
Yes, sir.
no need to write complete formula. So this is sine of 45 plus alpha, and this is sine of 45 minus alpha. Okay, so now tell me. Oh no, it will be 2 times that, right? It will be 2 times that. Okay, it is 2 theta 1, 2 theta 2. This will be sine of 90 plus 2 alpha, 90 minus 2 alpha, right? 90 plus 2
Yes,
alpha.
sir.
This will be 90 minus 2 alpha. Okay, and now what is sine of 90 plus 2 alpha? It will be cos of 2 alpha. Sine of 90 minus 2 alpha, it is also cos of 2 alpha. Okay, sine of 90 plus an angle, 90 minus an angle is cos of an angle. You know this or not?
Yes, sir.
Yes, sir.
Okay, if you know, very good. So this will be cos of 2 alpha, cos of 2 alpha. Okay, that's equal to 1. And if you don't know, you can always verify. But we have to do quick work. Okay, so we should remember this formula. So sine of 90 plus 2 alpha. It is sine of a plus b sine a cos b, sine 90 cos 2 alpha plus cos 90 sine 2 alpha. Okay, and cos 90 is 0, sine 90 is 1. So this is 1, this is 0. So second term vanishes. Okay, so it is cos of 2 alpha. And sine of 90 minus 2 alpha. It is sine 90 cos 2 alpha minus cos 90 sine 2 alpha. So second term will vanish. Okay, this will vanish. Right? So this is also cos 2 alpha, this is also cos 2 alpha. So sine of 90 plus something is cos of that thing, and sine of 90 minus something is also cos of that thing. Okay, that angle. This is clear?
Yes,
Yes,
sir.
sir.
Okay. So better we remember this, because yeah, this can be done quickly, but will still take some time. Okay. And second thing is, so when we have direct proportionality, so R is equal to what? U square sine 2 theta divided by G. Okay, so we should not write the whole formula and everything. Okay, just directly, because velocity is equal. So R1 by R2 will be sine 2 theta divided by, sorry, sine 2 theta 1 upon sine 2 theta 2. Okay, we have to increase speed, right? You got this?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so next question. For an object, okay, they they just love 45 degrees. For an object thrown at 45 degree to the horizontal, the maximum height h and horizontal range are related as. Tell me.
R is equal to 4H.
R is equal to 4h. Okay, this is from UKPMT. Okay, a body is projected horizontally from top of tower with velocity of 10 meters per second. Okay, if it hits the ground at an angle of 45 degrees, then the vertical component of velocity when it hits the ground is. Okay, this is extremely simple. See, it is projected horizontally like this. Okay, so it will follow this kind of path. So initially its velocity is just in horizontal direction. This is ux, and how much is ux? 10 meters per second. Now when it hits the ground, when it reaches the ground, tell me at this point how much would be horizontal velocity and how much would be vertical velocity. So horizontal velocity, does it change?
No, sir.
No,
No, sir. Okay, so it is Vx is equal to 10 meters per second. It is constant, and they are telling that it hits the ground at 45 degrees. So this angle is 45. This angle is 45. So if this angle is 45, then how much would be Vy? This is Vy. Okay, or in this triangle, this is Vy, and this is 45.
Tan 45 is equal.
Yeah, but if you have 45 degrees, then these two sides of triangle are equal, right?
yes,
Yes,
sir.
sir.
10 meter
10,
per second.
10 meters per second is the answer. Okay, we can do all that. Okay, Vy upon Vx is equal to tan of 45. Okay, so Vy is equal to tan 45 multiplied by Vx. Tan 45 is 1, and therefore Vy is equal to Vx. Okay, but before doing all that, we can easily guess the answer. If this is 45, then x component and y component of velocity are equal.
Yes, sir.
Okay,
Yes, sir.
so answer is D. The body is projected with an angle theta. The maximum height reached is h if the time of flight is 4 seconds and g is 10 meters per second square. Then the value of h is time of flight is given and maximum height is asked. How to do this? So h is equal to what? U square sine square theta upon 2g. Okay, time of flight is 2u sine theta upon g. Time of flight is given. This is 4. 4 is equal to 2u sine theta divided by g. Okay, so now can I substitute? So u sine 2u sine theta. Okay, so from that I can substitute u sine theta is equal to 4g divided by 2. Okay, I will take g on this side, 2 on this side. So g goes to numerator, 2 goes to denominator. So u sine theta is 4g divided by 2. Substitute that. So you get h is equal to, okay, what? 4g upon 2 square divided by 2g. So it is 6. Okay, 4g divided by 2. It is 2g only, right? This is 2g only. Okay, so it is 2g square. Okay, 2g square divided by 2g. So that is 2g only, 2 times g. So how much?
20 meter.
20 meters. 20 meters is the answer. Simple.
Yes,
Yes,
sir.
sir.
Okay, next one. So we have to do these kind of adjustments. Okay, so here t is given. So from that you can find out this unknown thing, u sine theta. All right. Next question. Next question. The velocity of projectile at initial point A is this thing. Its velocity at point B is, you tell me. What happens? X component remains same, Y component gets reversed.
2i minus
Option
3j.
option
2i,
C, sir.
option C, good. So X component remains same, Y component gets reversed. 2i minus 3j is the answer. Okay, very simple. Next one. An aeroplane is flying horizontally with a velocity of 600 kilometers per hour and at a height of 1960 meters. When it is vertically above a point A on the ground, a bomb is released. Okay, so aeroplane is there. Aeroplane is there. Okay, at height of 1960 meters, at this much height, and it's moving horizontally. It is moving horizontally with 600 kilometers per hour. Okay, so its horizontal speed is Vx is 600 kilometers per hour. Okay, and a packet is thrown. Packet is thrown, not packet is thrown, a bomb is released. Okay, a bomb is released from it. The bomb strikes the ground at point B. It strikes at point B. It will follow trajectory like this. Okay, so the bomb will follow trajectory like this. It will fall here. The distance AB is, how much would be the distance AB? This is the question, right? So see, this height is given. How much is h? 1960. Okay, so h is 1960. Okay, so you can find out the time taken by it. You can find out time taken by it to fall on the ground. Yes, no.
Yes, sir.
Using
Yes, sir.
which
Yes, sir.
formula? Using which formula? H is equal to half of gt square, because it has no velocity in y direction. So if you throw a bomb, then velocity in y direction is 0. Okay, it will hit the ground at some time t. So the distance covered in y direction is h. H is equal to uy times t minus, actually you will take it as plus, because okay, you are considering this direction to be positive. So uy times t plus half of gt square. Okay, and uy is 0, so it is half of gt square only, right? So you can find out
Yes, sir.
time from this. So it is t is equal to what? 2h divided by g, square root of 2h upon g. Or you can directly remember this formula too. Okay, the square root of 2h upon g, right? So let's substitute the values. So it is 2 times 1960 is the height divided by g. G is 10, or take 9.8. So this thing will get cancelled. 196 times 2. Okay, yeah, close to 400.
392.
Okay, 392. Square root of that will be close to 20.
Yes,
Square root
sir.
of 400 will be, square root of 400 is 20. We have 392. It's close to 20, right? And then you can find out this distance, the horizontal distance. Okay, so for horizontal distance, how will you find horizontal distance? Let's call it r. Okay, let's call it r. So r will be equal to what? It is vx multiplied by this time, right? So it is 600 kilometers per hour, and everything is given in kilometers. So we have to convert this time into hours. Okay, so it is 600 multiplied by, how do we convert it in hours? How to convert from hours to seconds?
3600 multiplied.
Multiply. Okay, so from seconds to hours, you will divide.
Divide by 3000.
Divided by
By
3000.
3600. Okay, so this thing will get cancelled, and so you have 36 by 6 is 6. Okay, and 20 divided by 6 is how much? 20 divided by 6 is 10 by t, 3.33. Okay, so this horizontal range is 3.33 kilometers. So bomb strikes the ground at point B. The distance, okay, this is above the point A. So this is your point A, right? So this is point B. Okay, so this is the answer, 3.33. I thought this point is A. Clear this? This is clear?
Yes,
Yes,
sir.
sir.
Okay, good. So next question. An arrow is shot in air. Its range is 200 meters and its time of flight is 5 seconds. Range is given, time of flight is given. G is equal to 10 meters per second, and horizontal component of velocity of arrow is. Okay. So range is given. What is formula for range? It is u square sine 2 theta divided by g. Okay. And time of flight, t is equal to, what is time of flight? It's 2u sine theta divided by g. Okay. So that is given. So now you want horizontal component of velocity. So this can be written as u sine 2 theta can be written as 2 times u sine theta cos theta divided by g. Okay, because range is given and time of flight is given. So can you write range in terms of time of flight? Yes, we can write this is 2u sine theta. Oh no, one u is missing, right? 2u square. Okay, I missed the square, but it's good. Okay, so this can be written as this thing. Okay, 2u sine theta multiplied by u cos theta upon g, and this thing is time of flight. Okay, so r is equal to time of flight multiplied by u cos theta, and you want the horizontal component of velocity. So it's simple, right?
Yes, sir.
Okay,
Yes, sir.
it is ux. So ux is equal to u cos theta, which is r by t. R is 200, t is 5. So 40 meters per second is the answer. Option
Yes,
D
sir.
is the answer. Okay, this is simple. All right. This one, horizontal range and maximum height of projectile are equal. Okay, this is different question. The angle of projection of projectile is. So they are saying horizontal range r is equal to h. So u square sine 2 theta upon g is equal to h, which is u square sine square theta divided by 2g, and we want the angle theta. So u square gets cancelled, g cancelled. Okay, so sine 2 theta is sine square theta upon 2, and this can be written as 2 sine theta cos theta is equal to sine square theta divided by 2. So this thing gets cancelled with this thing. So you take 2 on this side, cos theta on other side. So you get what? Sine theta upon cos theta is 4. So 4 is equal to tan theta, and therefore theta is tan inverse of 4. It is the answer. Option B. Okay, simple question,
Yes, sir.
right? If you know the formula, the questions on projectile motion are like this. Know the formula, it's simple. If you don't know, it's difficult. The equation of trajectory of projectile is, this is the equation. If we assume that g is equal to 10 meters per second squared, then range of projectile in meters is. Okay, so we have to find out range. So do you remember equation for trajectory of projectile? Y is equal to tan theta multiplied by x minus was half of gt square, right? And t is equal to what? X upon u cos theta. Okay, so minus half of,
18, sir.
oh, you found, very good.
Yes, sir.
Okay, let me check. Okay, let me catch up. So it is x square upon u square cos square theta. Okay, so tan theta is 10 and it is 5 by 9. Okay, and you have g also. So g multiplied by this, half of g multiplied by this. Okay, so it's 5 by 9. So this is u square cos square theta is equal to 9. U square cos square theta is equal to 9. And you want range of the projectile. So tan theta is sin theta upon cos theta is equal to 10. Okay, so sin theta is equal to 10 times cos theta, and the range is r is equal to what? 2u sin theta cos theta divided by g. And from this you have u square cos square theta. So from this you can find u cos theta is equal to what? 3. Okay, and sin theta is 10 times cos theta. Okay, so 2 times u sin theta, it is u square. Okay, so u cos theta sin theta multiplied by u sin theta. So sin theta is 10 cos theta. 2 times 10 u square cos square theta, which is 9, divided by g is 10, right? So you calculate it so fast. So this is equal to 18.